Alright, if we talked about, we know that the Earth revolves, evidence, seasons or season constellations. How do I know that the Earth is rotating? Remember, rotating, it's spinning on its axis. Do not tell me day and night, because day and night, it could show that the sun is actually revolving around the Earth, not necessarily the Earth rotating or spinning on the axis. Foucault's pendulum. So the whole idea, I'm looking at a non-fixed arm, so it can pivot. If I attach it to the ceiling, it's going to keep swinging in the same direction. With that one, it's just knocking the pendulum, knocking the pegs off that 180 direction from it. I'm going to insert a little video for you showing me actually doing this at the lab table with wooden blocks and a Lazy Susan. So you'll have a better idea what I'm talking about. Alright, here's my version of Foucault's pendulum. I have my Lazy Susan, my pegs are my wooden blocks. So my keys are going to be the pendulum. So remember, Foucault's pendulum shows that the Earth is rotating. So if I start, my pendulum's right here. It's going to keep going. Notice my pendulum stays. It's only knocking these blocks down. They have to be 180 degrees from each other. Now, if the Earth wasn't rotating, the pendulum just stay here and wouldn't knock the other ones down. But because the Earth is rotating, so are the pegs that are on the Earth. So what you'll see is with each one, whoops, wasn't going fast enough. As I rotate, each peg is going to get knocked down. Hopefully that makes more sense now to the drawing that's in your notes. So the pegs up, haven't been knocked down yet. The pegs down have been knocked down. Notice it's got to be 180 degrees apart. All right, thank you. Coriolis effect. In the northern hemisphere, objects are going to get deflected to the right, and in the southern hemisphere, they get deflected to the left. If you didn't have the Coriolis effect, your objects would go straight either north or south, and they don't. They veer. I'll post a couple other little videos that show you the Coriolis effect and the Foucault's pendulum. So be looking for that outside of your notes. It's going to be in the stream. And as I said earlier, day and night is not evidence of rotation. All right, it's going to take approximately 24 hours for the Earth to make a complete rotation. The whole idea rotates counterclockwise, west to east. So the East Coast actually gets the sun before the West Coast of the United States. The speed of the rotation is going to all depend on your latitude, because your latitude, with that one, if I look at the equator, latitude-wise, the equator has more distance to cover in the same amount of time, so it's got to spin faster. As you move north or south of the equator, those latitudes have less distance to cover, so they actually move slower.